Today's target problem is car washing. And the object of this model is to simulate a car washing place. And in this process, the key elements that have to be considered in order to implement the property of car washing systems. First is a resource. Resource is required for the limited number of washing machines. And second one is the process. The role of the process is to clean the car with the available resource. So the class or function of this model is composed of washing machines and the car that would be cleaned. And also there is a limitation of the washing machine, and that limitation will be treated as a finite number of resources. And also each car that is arrived at the car washing place is designed and implemented as a process class. The overall procedure is like this. We need to, in the start of the simulation, there are 2 car washing machines in the car washing place, and each car is arriving at the car washing place according to the given inter-arrival time. The 4 cars arrived at first. Actually, in this figure, there is 3 cars. Then car arrives one by one from next. And only 2 cars could be washed at a simultaneous time, simultaneously. So the others have to wait at the front of the car washing place. And the arriving interval is designed with a given inter-arrival time. When the one of the washing machines job is completed, then car is leaving the washing machine, and one of 2 the resource is being available, and next car is input to the car washing machine. This loop is iterating until the simulation, this is the typo error, until the simulation time is done, or if you assign a finite number of cars in your simulation program, then the simulation will be finished after all the cars are being washed. So the scenario is not so complex, it is a little bit easier. So in this problem, first variable parameter is inter-arrival time. That inter-arrival time is the duration between each cars arriving. And the second parameter is the service time of each washing machine. In this example, these 2 times will be modeled as a stochastic distribution. Also, there is one more parameter, that is the capacity of the washing machine. In this figure, there is only 2 washing machines, so no, this capacity is not the number of it. This capacity is the, I need to see the code. A capacity can be a number of resources or the number of the work available number in each washing machine. So wait a moment. In this example, capacity means the number of a washing machine. So in this example, there is all three parameters. And after the understanding of this example, you can test your own scenario by changing each numbers or each distribution. So there is two key concepts. First one is the resource here. Resource is a way to model process interaction. And resource is one of a kind, one of various resources. Actually, there is a various kinds of resource. The basic resource means any facility or equipment that have a finite number of capacity. Or there can be another kinds of resource, so-called store or what kind, wait. There is a moment. There is representatively three kinds of resource. First one is a basic resource, and the second one is a container. Container resource, it's model the production and consumption of a homogeneous work. It means that in case of containers, all the belonging, the object have to be same type of entities. That is a container. But in case of stores, store is also one of a resource object. That store resource allows the produce or to consume of any kinds of Python object. So the store resource is more flexible compared to containers. So in this example, we will use the basic resource. And this basic resource is being used with a limited number of processes at a given point of time. So, and this resource object processes are, if we assign the request resource command inside of the process class, that this process will be paused. It means that it will be stopped at the point until the assigned resource is available. And specifically, this process that we want to use the resource, request or release the resource by calling the request function or release function. But in our exam, in current version of SimPy, this command is not used. In this example, means that request will be used, but there is explicit use of release is not available anymore. So this release is being triggered automatically after the use of the unspecific resource use. So next key concept is waiting for other processes. Waiting for other processes is one of a kind for the implementation of process interaction. The process can be such as kinds of event, So it can be also, this waiting processes can be also yielded inside of the other process. Means that the waiting process itself is an event generator, because the waiting means that by triggering the waiting at a point of time, that means that is to yield any kinds of conditional events at that point. So if process A is yielded inside of another process B, then process B will wait for process A to get triggered, or the process, if the process A is to wait, then process B will wait until the completion of the process A. We will see these two kinds of the key concept in our example. This is the entire code. So, moment, let's see first the clean sheet first. Do you remember the online document that you can find all kinds of example code and also the related contents of the SimPy in this address. So please save this address in your web browser, and you can find and you can check any kinds of command or example or any introductory materials in this address for the learning of the SimPy. This is the entire code. Firstly, we import a random package and SimPy. And also, random seed is defined as 42, but you can change this number to any other value of numbers. By changing these numbers, you can generate you can conduct a stochastic simulation. By changing this number, the result of simulation will be changed according to this random seed. We set the number of a machine as 2 here, and washing time is, in this example, washing time is defined as a deterministic time, because here the time as an argument of timeout, this washer time is used directly as a deterministic value instead of stochastic distribution. And interarrival time, following the average duration of 7 minutes, and all the simulation time is being set as 20 minutes. You can see here, the running time can be decided as by inputting any number of the simulation time that you want with the until keywords here. And there is car wash. There is only one class That class name is car wash. And inside of this class, there is init function and wash function. And also there is a car function and setup function. So this example is already implemented as designing of only one class and with of 4 functions inside of this class. Let's see the starting point of the simulation. There is a toPrint command and the random seed number is given here. And firstly, we define this env variable as a SimPy environment. And only here we trigger the process. We process, not triggering. It is actually this is the purpose of this command is to make a model. So environment.process means making a model, and this model is, if there is more code, this is what code. This code is starting with the setup function here. And after this model, this simulation is started here. Actually, the entire structure is the recursive way, because the outside of the definition of car wash class, there is only the setup function is called in the process model. There is no explicit representation of car wash class here. Instead, car wash class is being created inside of this setup function. So I needed to check one thing. Wait a minute. I think that I'm sorry that there is some wrong explanation. The init function and wash function are included in this class, and this car and setup function is not belonging to car wash. It's these two function is the independent function from the car wash class. We can see this entire structure by indentation in the actual code. So my previous explanation was wrong, okay? So this simulation is started by calling this setup function. And in this setup function, this car wash class is being defined and called here. And from here, in this setup function, the simulation model is being implemented here. It means that inside of a setup function, the car wash class is being declared and actually declared. It's called. The car wash class is called. And also this car function is being called for the makeup process model here. So let's go to the next page. We set the information for the cars and create environment and process setup. And the next page, so in this setup function, car wash class is being called, and the argument of number of machines and wash time is being given and transferred to the car wash class. And also, in this set of function, by using this iterative structure, yielding the timeout event with the random duration. So in this example, the random integer stochastic distribution is used. It means that between these two numbers, this t underbar inter is defined as this variable, this global variable. And between these two numbers, the random integer variable is being returned from the random function. So this timeout will consume the amount of time. Then that amount of time is the integer type of number. And by this while, and inside of this while, generating the timeout event, the car function is being modeled here. So in this example, there is no the ending point. If we do not assign a finite time here, this example is not finished until by forcing stop of the simulation. So in this setup, we call the car wash class and make the car process here by calling the car function. And also we generate a timeout event with a given inter-arrival time. And also here each car function is being called also here. Or wait a moment, create. In this loop, this part and this part is separated. First part is the initial state. That means that in the start of the simulation, at time zero, point of time zero, these 4 cars is being created. And after this creation, with the given inter-arrival time, by iterating this loop, the another cars are being created in this part. And also one more thing that have to be pointed out is this car wash class is being transferred to each car function as an argument here and here. And as soon as we call this class here, car wash, actually here, the number of machines and wash time from here and from here transferred to the argument. And in this car class, these two numbers is being announced as internal variable of this car wash class at the init function, that is environment itself, that is belonging to itself, and the machine is created as a given number of machines, and also the wash time of this car wash class is being defined as the transferred wash time from this car wash creation place. And next, go to the next to the car class. It means that by modeling this car, the car function is called. So we needed to see what is happening, what will be happen at the car function. Here, inside of the car function, the resource is being used for the waiting until the available resource is being prepared. Actually, previous lecture, we already have seen the use of the resource with the with as and the request function. So when we create the cars in this loop or in this loop, each cars is being created with this function. So as soon as the car is being created, here in this loop or in this loop, this function is being triggered. It means that as soon as the car is being created, the waiting resource event is being started here. So this CW means that here car wash class. Here. This car wash class as an argument is transferred to the CW variable. Maybe all of you know the programmatic grammar by calling the function. So you can change anytime the argument name when you pass it to another function or another class. So by calling this car class, the car wash class, we can use where is coming from the motion? We can use the motion is the resource here. You can see here, the motion variable of car wash class is being declared as a SimPy resource with a given number of motions. So this is a car wash class that calling the resource, and because this resource is being declared as a SimPy resource, so we can use the request function that is belonging to the resource class of the SimPy. And we are yielding this request. And by yielding this request, the waiting is started here. But if at this point of time, if there is an available machines for the car washing, the waiting time will be 0. It consumes 0 time. But if there is no available machines, that this yielding event will be started of the waiting. And as soon as the one of washing machine is becomes available, then this waiting is being finished and jump to the next point. And here, the event generating is triggered by yielding the process. This process is a washing function. This wash function is a member function of car wash class here. So this is the calling the another process inside of the another process. So in the car process, we call the wash process that is belong to car wash class. So even though this car class is the another process, but the wash process that is belonging to another process can be called here. It means the car process is able to use the another process that is wash. So environment.process, and inside of this process, the another process is being called. And the argument is the name of the car. So by transferring this name to the wash function goes to here. In this wash function, building the timeout event and print out the car wash removed statement with the name of the cars that is being the wash finished. Okay, after this, this statement is being printed out. Okay, and what is this? It's not the key point of this example, but this car wash removed this number of this number. So this the letter 1 is the number of cars, the name of the cars. So the character reference is being assigned here, and this number is the random number. So in this example, it just use the integer random function between 50 and 99. So any random number will be printed out between these two numbers. For example, car wash removed 70% of the car one's dirt. That is just the transfer, but if it may be possible to use of this number as the program entity. And if, for example, if the percentage of washing is under 60 or 70%, in the case, this car have to be re-enter the car washing system. That kinds of simulation can be implemented if we use directly. If we directly use this number, but in this case, it's just for the visualization of the information of this. So this is so again, let's see how this code is being structured. So in this example, the starting point of is the calling this setup function, and in this setup function, we create the car wash object, and also we created initial 4 cars by calling the car function. And after this, we continually create another cars iteratively without the ending point with this inter-arrival time of stochastic distribution. And in this created car wash class, we call the car wash class. And inside of this car wash, there is the resource is defined, and also the wash function is defined. And inside of the car class, there is a request function for the car washing with a finite capacity of washing machines. And also, the inside of car, we use this car process use the another process that is a wash function. And also this wash function is belonging to another car class. So this is the one of a kind of interaction between different kinds of processes. So if we customize this structure among any kinds of processes, we can design and implement the another kinds of interactions between each processes or between among the another kinds of machines. And also with this process interaction, and additionally, if we add the kind store resource for the information sharing, we can pass the products or the interim products by passing any kinds of Python object, Python entity from the one process to the other process. Actually, this mechanism will be presented at the sim component, the lecture. Sim component is actually the customized sim component was implemented by use of these kinds of process interaction, and also the additionally adapt use of store resource. So this resource is not the only simple physical one. Instead, we can very flexibly use the type of resources for the information sharing between the other kinds of processes. So let's see the actual code and let's run the program. So this code is exactly same with the explained code. So there is a global variable for the simulation, and this is a car wash class. Inside of this car wash class, the init function and wash function is defined here. And another two function is being coded here, two function. And set up and start the simulation here. So let's run the simulation first. What is being 이게 뭐지? 여기 뭐가 있나? Anyway, the first car, Zero's car arrives at the car wash. So we created 4 cars here. So as soon as the simulation is started, the 4 cars is being created at time 0. And very surely, first car enters the car wash because 2 machines are available at the start of the simulation. And during the car washing, the 4th car arrives at the car wash at this time. And actually because we assign this arrival time as interval number, so all the time will be integer instead of any point of numbers. And here, these 2 cars wash is being finished, and we have assigned the car wash time as deterministic duration 5. And also there is no stochastic distribution. These 2 car washing are finished together. But this number is not same because this random variable is being created. But this number is not important. It's just for showing. And after this car wash, these 2 cars are leaving the car wash machine, and 2nd and 3rd car enters car washing. In this way, the simulation is being progressed until the time 20. If we increase this time, so many cars will be treated. And also we can change the number of wash time by calling this number here. This is 5. So how about this? Between this time, so you can see here, the leaving time of 2 cars are now being splitted. It's not moved together. So you can change any part of this simulation.